So this is problem number 14, and it is just algebra. We are trying to accumulate 8,000 after 3n years. We make deposits of 98 for the first n years, deposits of 196 for the following 2n years. We've got this little formula here is given to us, and then I've written out our accumulation formula. And note that our deposits and our accumulation value take place at the end of the year. So we're using the immediate version of the formula. So let's write out an equation. We are trying to accumulate 8,000, and we're going to do that by depositing 98 for the first n years at some unknown interest rate I, and I'm going to leave an empty spot right here. And then we're going to accumulate, or rather make deposits of 196 for the following 2n years, again at some rate I. And I've left this blank spot here because think about what's happening. We make deposits of 98 for the first n years, and then we just sit on that and start making deposits of 196 for the following 2n years. So this first chunk of deposits is going to have to accumulate interest to bring it all the way to the end of our accumulation period. So I'm going to add this term here, 1 plus I raised to the 2n. And I suppose it would be a bit easier to see that if I wrote it out on a timeline, but I will leave that to you, the viewer. So from here, it's basically just algebra. Let's replace this S sub n, this annuity accumulation formula, with the actual value of the formula that we can use in our calculator. So we have 98 times 1 plus I to the n minus 1 over I times 1 plus I to the 2n plus 196 times 1 plus I to the 2n minus 1 over I. And we can do a substitution directly here, and we can also see that if I square both sides of this little given statement here, I've got another substitution that I can do. So let's rewrite that as 98 times 1 plus I to the n is 2, 2 minus 1 over I, times 1 plus I to the 2n is 4, plus 196 times 1 plus I to the 2n, again is just 4 minus 1 over I, and we can simplify that down a little further. This just becomes 98 times 4 over I plus 196 times 3 over I. And at this point, you're either great at mental math or reaching for your calculator. 392 plus 588 over I is equal to 8,000. Combine the terms together and simplify, solve for I, and you end up with I is 49 over 400, which is 12.25%.